Hi, this is Kevin. Welcome to my tutorial for Zelle Chapter 6, Exercise 4. This is a custom exercise. It's not the one from the book. So my tutorial is going to do the following thing. The skill that we're trying to demonstrate is we want to demonstrate that functions can change the original value of mutable variables passed to them as parameters. And we want to show you how we could exploit this property in a useful program. Okay, this is the thing that is done. It's not considered a bad programming practice when you do it on purpose and explicitly. And what's the example that we're trying to do? Well, let's just take a list of strings. Strings are the only mutable objects that we've learned about so far. Well, let's take a list of strings and pass that to a function that will do two things to it. It's going to shift all the strings to uppercase, and it's going to sort the list alphabetically. Okay. Now, just before we dive in, I want to tell you that the phrase up there in the skill blurb, mutable variables, that's not really a carefully chosen Python turn of phrase, okay? Because variables in Python are just really labels, and they're associated with values, and it's the values that have all these properties, okay? So values have a type, okay? Typically associated with some class, okay? And those types are typically known to either be mutable, changeable, or immutable, unchangeable. So we haven't learned a lot of types so far. We've learned about integers, floats, and character strings, and lists. Okay, and of them, all integer, float, and string are all immutable. Okay, so we can't use them in order to demonstrate this. So what we're going to do is we're going to create a list of strings, and a list of strings should be mutable, should be changeable, and we're going to find a way to exploit that. So let's get started. Let's define a main. As usual, we're not going to pass in any parameters. And let's go down here and have a call to main, usual ways. And let's here, as code for main, let's first create a list of strings. Okay, so let's call this a phrase list. Okay, and let's assign it the value of, first of all, the empty list, and then let's just put a bunch of strings in it. I'm going to put Hal, Now, Brown, and Cal. Hal, Now, Brown, Cal. Now. And Cal. Okay. And as usual, I want to test as soon, as early and as often as I can. So let's just say print phrase list. Phrase list. And let's see it print. Okay, so we're going to run it. And let's go down and look. And this is what happens when you print a list. You see the square brackets to say it's a list, and then you see the individual, if they're strings, they show up looking like this. Okay, that's great. Now, what we want to do is we want to turn it around such that when we're done, everything is in caps, and they are in alphabetical order. All right, so let's do that. Now, I just want to point out that there is the way to achieve what we're trying to achieve without exploiting the ability of mutable objects to be changed in called code, is to simply pass in a phrase list and then send one back, right? Let's show that first. Okay, so we have a phrase list. Okay, so let's have one that's called processed phrase list. Okay, equals change me. That's going to be the name of the function we're going to call, and we're going to pass it the phrase list. Okay, change me phrase list. Oh, and what's our problem? Well, we don't have a change me. So let's define change me. Okay. And this one does have parameters, so we have to say what's the formal parameter here. So let's say the list. Okay. Sorry. Too much Java. Too many cups of Java today. Okay. We have this. Okay. And then what we do is we do like all the work that we're going to do. Okay. And we, when we're done, we just return a value. So we could say return. Okay. And then what we return, well, we return a list. And let's see what would be in it. Well, all caps. How, let's see, how now brown cow. So first one would be brown. Brown. Okay. And next one would be cow. C. And the next one would be H. How. And the next one would be N. Now. Okay. So when we're done, we could say print processed phrase list. Okay. And we would get the processed one back. Okay. So you might say, well, Kevin, you cheated, right? You did all this stuff yourself in your head. You didn't really do the computing to get it done. But as we're going to see, there is a computing to get that done. But the question is, how does the plumbing work between the two methods? And this one is the standard way where you don't rely on the ability of the code to induce objects to change themselves. Okay? Corrupt them in some sense, right? So it doesn't really change me, okay? Because if we come back and we look at, that's the process phrase list. If we come back and we print the phrase list again, it's not changed. Sorry. Where are you, buddy? Right here. So print phrase list is here. Okay, we probably could use another blank line. But if we run this as a test, you'll see, the original list hasn't changed. Okay. So this is the classic way, this is classically clean code where we're not really relying on any objects to change themselves. Okay, even the ones that are mutable or changeable. Well, why might we want to induce an object to change itself? Well, we might want to induce one to change itself if it's a pretty complex object and we don't want to create a copy of it. Okay, we don't want to have to completely copy the object over, change some parts of it, and then return that value back. Okay, that's a lot of constructing of the new object. How about because in these object-oriented languages, how about we just very politely call the methods on that object and ask it to change itself? Okay, that kind of makes sense. So we're not going to do it with a return value. So let's not do that. Okay. And then let's not call it change me. Let's call the method that we want to call. Let's call it let's call it capitalize and sort. Okay. And we want to do that to the phrase list. Okay. Oh, we don't want to fool with this anymore. We're not going to have two different things. Oh, okay. We're going to capitalize and sort the phrase list. And then let's just go down and create a definition for that. So def capitalize, and sort. And we're going to need some kind of a formal parameter here. So we're calling it with something called phrase list. I always like to emphasize that phrase list is really only known up here. We can use that name again, but it really doesn't refer to the same thing. It takes on a whole new meaning because the scope of variable names is limited to the code block that they're created in. Okay, so phrase list is only known inside of main. So if we're going to pass this as an actual parameter, and we're going to pass it to this capitalize and sort, I like to use a different name just to emphasize this isn't the same variable, but this is going to be a copy of the reference to it. Okay. Let's call this one parameter phrase list. Okay. So this is the parameter, the formal parameter that we that we define in here. And that's the name by which this is going to be known in here. Okay? All right. That's pretty good. So let's do something that's really going to pay off fast. So the first thing I see is that capitalize and sort has not matched up yet. So somehow those names don't agree. So I'm going to highlight one, copy it, and I'm going to paste it over top of the other. And now, whether they're properly spelled or not is an open question, but whether they're spelled the same is not. We know they're spelled the same now. And now they're okay. Okay. So what could I do to this? Well, let's just do something weird. Let's just say x equal 2. Let's just use some nonsense code here. And then let's, so we print the phrase list, we capitalize and sort it, and then we print it again. What's it going to be? Well, I think it's going to be the same. Okay, let's give it a test. Okay, yeah, it's the same. So it is neither capitalized nor sorted. Okay, what if we could do one really easily? Okay, that sounds promising to me. What can you do really easily? Well, if you look up the methods you can call on a list, one of the methods you can call on list type things is sort. So let's just take the name that we know the list by in here is parameter phrase list. Okay. And let's just call sort on it. Okay. Now, I'm not saying some new list equals parameter phrase list dot sort. Okay. I'm not, a sort doesn't throw off a new list object. Sort actually induces the list to change itself using its sort method. Okay? Why does it do that? Well, what if your list was really long? Would you really want to, let's say you had 1,000,000 things in your list and you wanted to sort it. Would you want to have to create a second 1,000,000 item list in order to get it into the right order? Perhaps you'd use up too much of your memory that way. So some of these things are better done kind of in place. And sorting is one of them. So we're going to call sort, we need a paren. Okay, and let's just see that. So I think what's going to happen now, you think about it, but I think when we say capitalize in sort phrase list, what's going to happen is it's going to be sorted but not capitalized. Let's look at that. Oh yeah, now look. It is sorted because it's coming out in the same order that we pretended before. B before C before H before N. Brown cow, how now? Okay, we've got most of what we want done. Okay, now when we have a small object like this. Okay, a list of 4 short strings. The difference between this approach where we change the object in place and the other one, the first one I showed, where we don't change it in place, we create a new object and we pass it back as a return value. Well, there's 6 of one, half a dozen of the other. But like I said, as the list gets longer and longer, or as the object, whatever it is, gets more and more complex and is composed of sub-objects and sub-sub-objects and all that kind of stuff, it becomes infeasible. It becomes really expensive to construct a whole new value to return. And so this change things in place as a use case becomes very attractive. Okay, so we're able to do it with sort. Now, how would we do something like this to capitalize it? So what we want to do is we want to go through this, and we would like to change each item. Okay. Well, it'd be really nice if lists had this sort of ability to just replace one thing with the next. Okay. And what's kind of easier to do and cleaner to do is to iterate over the list, find the location of the item that you are looking for, the item that you have, find its index, okay, do a remove, that's one of the methods you can ask for, and then do an insert to that location. Okay, so this is a case of, instead of changing, we are deleting and adding in place. Okay, shouldn't be too hard to do. So how do we iterate over a list? Well, we say for, and let's call it word in parameter phrase list. Okay, so that's how we know we're going to get word. That's what we want. We're going to need a colon there. All right, and now what are we going to do? Well, the first thing is we're going to save the location of the word that we're on right now. Okay, and I'm going to call it this index. We're going to assign it the value of parameter phrase list index, and then we're going to pass it the word. Okay? So what we're going to say is, okay, just look up the one you have, look up and see what the index is on the list. Okay? This seems a little bit complicated, but it's a very straightforward way to do this. Okay, so then we know where it is. Okay? Now, let's remove the word from the list. Okay, so let's just say list remove. And what are we going to do? Well, we're going to remove word. Okay. Okay. And then how do we make sure that we're going to insert it in the right place? Well, we know the index that we want. Okay, so let's say, I'm sorry, we didn't want to just say list. We wanted to say parameter phrase list. Yeah, parameter phrase list. So I'm going to copy that expression and put it down here, because this is what we really mean. Okay, so we're going to remove that one. Okay, and then let's take parameter phrase list and let's call another method. So call. We're going to call the list. We're going to call what? Well, we're going to call insert. And what we're going to insert? Well, it turns out that that takes two arguments. It takes the location, takes the index you want to put it in, and it takes the object that you want to pass. So the location is, of course, this index, because we saved it in something called this index. And what do we want to do? Now, the problem is that we removed that word before we did anything. So let's save it. Okay. So let's call it word in caps. And let's assign it word upper. A little too much Java there, too. Java statements end in semicolons instead of nothing at all. Okay, so word in caps, we save that because what I'm a little bit concerned that when we removed the word from the list, we may have clobbered this. Okay, so if we go back and try to use it to have a call to upper, it's not going to work. But I know I've saved word in caps. Word in caps. I know I've saved that there. Okay? And that's it. I'm just going to go through each of them, and I am going to remove the one that's in lower or mixed case, and I'm going to replace it with one that's in upper case. Okay? So let's see. I think it's probably all the code we need. So let's make sure we're skipping 2 lines. This looks pretty good. That's the 3rd line. So, all right. So this looks good to me. Let's see how this is going to play. So make sure this is saved. Give it a run. And let's go down and see what we have. It's all in caps. Brown, cow, how, now. Okay. Now this is interesting. Okay. So we're going to capitalize and sort, and it looks like we've done them both. We've capitalized and sorted, And but you know what? Literally, we're not doing it the same way. We're doing we are first sorting and then we're capitalizing. Let's show that we could have done them in the other order. So let's move this down here. Okay. And let's move this up here. Oh, I'm sorry. That's not supposed to be part of the loop. That's supposed to be after the loop. So let's move that out one. It's on the same as the 4. Okay. So we're going to come in, and this is the code that's going to shift it to uppercase. Okay. It doesn't really shift them. It takes each of the entries in the list, and it creates an uppercase version of it and saves it in a temporary variable. Well, it saves it in a variable that where it can get to it. Then it figures out the index of the one it's on, and then it does a remove, which it can do by simply passing it a reference to the object that it wants to remove, and then it can do an insert because we've saved the index and we've saved the word in caps. Okay, so let's do this in the other order now. So let's give it a run. That looks good. And that still works. So how can we tell the difference between a code that works like this, takes advantage of the ability of mutable objects to change themselves, and code that doesn't? Well, 2 things, okay? Code that doesn't take advantage of that will always create new values through an assignment statement, okay? So when we say word in caps equals word upper, it turns out that word is a string. Strings are immutable, okay? So anytime you want to appear to have changed the value of a string, what you really do by calling upper is you get that object word to create a new copy of itself that's in uppercase, and that's what you're assigning here. So when you're working with immutable objects, you are always assigning a value. When you're working with mutable objects, you don't have to assign the value at all. So what's happening here in these last 2, okay, where we do a remove and when we do an insert, we just have the name of the variable that refers to the object, and then we're calling a method. Is this a method that returns a new instance of that kind of thing? Does it return a new list? No, it doesn't. It asks the list to change itself. So in this object-oriented world, we have some objects that are immutable. You can't ask them to change themselves. The nearest thing that you can do is you can ask them to create a new object that's like themselves. Perhaps exactly like, perhaps like it with shifted case, all that kind of stuff. But if you have a mutable object like this, you can actually ask the object to change itself. And how do you ask objects to change themselves? You call their methods. Okay? Now, let's talk about whether that's polite to do or not. Okay? It's polite to do if it's within your kind of charter as a function or a method. That's why I decided to call this method capitalize and sort. This sounds like we're changing, okay? That's our authorization to ask this object to change itself. We want to capitalize and sort it, okay? So it's not proper to, if a calling code should pass you some parameter, and your charter is not to be changing things. And it's not really polite to go making calls to ask these objects to change themselves. But so long as it's within your sort of approved mission statement, which I would say is true for capitalize and sort, then it's just fine to get these objects and call their methods and ask them to change themselves. We're not changing them. They're changing themselves with our coaxing, okay, by calling their methods. And then when we get back to the called code, we're using the exact same name. We're using the same variable name, pointing to the same object. It's the same object. It's an object that has changed its state because the function that we called induced it to change it. But that's okay because that was part of the mission that kind of a function had. So that's how we get objects to change themselves and how we can exploit that in functions or methods that we call. And what you're going to do when you do your version is something different. I'm capitalizing and sorting. You're going to do something else to a list, okay? And you're going to follow our sort of approach here, and you're going to see that we can ask mutable objects to change themselves in place. Okay? Completely okay, and especially an okay thing to do when these are long and complex objects and we don't want to be having to create copies. So that's it. Good luck. See you next time.